right, hello. Welcome back. You missed it. No, you missed us. We're into chapter 8. You're going to find that this is chapters 8/10. Gonna put some things together. Chapter 10 is a bunch of 2 sample stuff. We're going to combine with our 1 sample stuff. What are we doing with our 1 sample? In chapter 8 here, we are going to be creating, and you might go ahead and write this up on the front, confidence intervals. The whole goal of this unit is to create confidence intervals. What do we do? What are we doing? We're really estimating. We estimate with confidence intervals, and that's the idea here of 8.1. We're not actually going to do any math today. Section 8.1 will introduce the notion of a confidence interval. 8.2 and 10.1 will make confidence intervals for proportions. 8.3 and 10.2 will make confidence intervals for means. Sounds like the order we saw in chapter 7. You're going to see that kind of pattern from chapter 7 where we introduce a major concept followed by applying that major concepts to proportions and means. That pattern is going to kind of hold over the next 3 chapters. So also I am trying to, I'm sharing my document camera a different way than usual. If it is indeed higher resolution, it looks like higher resolution to me. If it is indeed higher resolution, let me know and I'll continue sharing notes this way because I think this is better. So you see chapter 8, vocabulary, important. I'd be making vocab cards. I'd be making note cards. If you haven't been making note cards, what are you doing? Please, good God. If you haven't figured out this class is about the vocabulary, you need to make note cards. Again, probably making, one large note card for each of these different types of intervals, and then the vocab, you might combine that if you want. I don't know. So 8 and 10, there you are. And we're getting into here to chapter 8, estimating with confidence. And when you see this word estimating, what you need to think is that we are going to construct a confidence interval. When we see that that estimate prompt, it's time to make a confidence interval. I'm often going to abbreviate confidence intervals CI, confidence interval. A lot of abbreviations in this unit. Want to make sure you keep those straight. So we have some definitions to begin with, and I'm rolling over my cord already. Definitions begin with a point estimator. What is a point estimator? That's the statistic that provides an estimate. The value of that statistic is called the point estimate. So the estimator is the statistic. The value it takes is the specific estimate. So the point estimator, that is, in our case, p hat or x bar. The estimate is the value that it takes. So why do we care about that? If we don't have any other information, our best guess of the proportion of people that are going to vote for Joe Biden or the average height of people at Park Hill High School, our best guess for those things is the proportion that we get from the poll or the average that we get from the sample of people from Park Hill High School. Our sample statistic goes in the middle of our confidence intervals. We're going to see that here. This is our starting point. This is our starting point for the best estimate. So this is kind of a starting point. If we're trying to guess what something is, we're going to use our statistic from our sample as our starting point. And we'll make some adjustments from that estimate. Multiple choice, the statistic has a sampling distribution whose mean is different from the true value of the parameter. Well, if the mean is the same, we call that unbiased. So if the mean here is different, we're going to call that a biased statistic. Okay, I don't know why I still have that in there. It's just kind of a reminder from chapter 7. I guess I do know why I have that in there, because you need to go back and if you don't know chapter 7 vocab, you need to review chapter 7 vocabulary. And if you haven't taken the 6-7 test yet, either online or in person, you need to let me know as soon as I see you, and we need to get it done. I haven't started grading it. I didn't grade over the break. And if this is being used for a later year, sorry. So here's the idea of a confidence interval, the big idea. You see it here. Take a moment to read. The C% confidence interval gives an interval of plausible values. Put a little box around that phrase, plausible values. CIs give plausible values. Where could it be? What does plausible mean? If you don't know what plausible means, possible, reasonable, it would make sense. Zoom in, there we go. All right, so the interval is calculated and has the form. Okay, so here we have our very first formula. We're not actually going to get to plug any numbers into it today, but here is our formula for a confidence interval. Your point estimate plus or minus your margin of error. What's that going to look like in practice? So it's your estimate plus or minus your margin of error. You don't know how to calculate those right now, but for now, we do know what the estimate would be. The estimate would be either the p hat we calculate, plus or minus margin of error, or the x bar we calculate, plus or minus the margin of error. Our p hats and our x bars, those are going to be our estimate for mu or excuse me, p or mu. Remember, we talked about these as unbiased statistics, so on average, they tend to get it right. The difference between the point estimate and the true parameter will be less than the margin of error in C% of all samples. So what do we see here? What do you see here? Confidence goes up. As your confidence level goes up, what do we see to our what happens to our confidence interval? It looks like, here's kind of the middle. As the confidence level goes up, the confidence interval gets wider. If we're more confident, we're going to cast a wider net. If we're casting a wider net, we are more confident. Write that down. Wider interval equals more confident. More confident in what? More confident that this interval is going to capture the truth. As the confidence interval gets wider, what happens? Our confidence that the interval captures the truth, and I'd like you to write that in all caps, underline it, highlight it, captures the true, what are we talking about? Parameter. Our confidence that the interval captures the true parameter. We're trying to make an interval that finds the truth. You go online, you can go to CBS.com right now, CBSNews.com, Fox News. You get a poll for the upcoming Georgia special elections. You can get, this is Ornock plus or minus whatever his name is. I don't know what his name is. But what we're trying to do, we'd like to make an interval that has the truth in it. If it captures it, that means it has the truth in it. We want to make an interval that captures the truth. And if we make wider intervals, they are more likely to capture the truth. But we lose something when we make a wider interval. What happens? Well, we lose something as we just make our intervals wider and wider. Why not make a 99% confidence interval? Why not just increase that? Well, we'll talk about it. Margin of error. It talks about margin of error here. Margin of error, that's what tells us how close, read that paragraph, tells us how close the estimate tends to be to the unknown parameter in repeated random sampling. What does the margin of error account for? It accounts for sampling variability. Different samples give us different results. So now I said that over and over and over again. And you've got these distributions over here, which I had on the board and you wrote down for your test. I have those distributions about how p hats and x bars are spread out. There's variability. There's natural variability built into these estimates. They're not going to get it right every time. There's going to be some variability around the truth. That's what the margin of error accounts for. What it doesn't account for is a bad sample or a biased survey. Well, let's take a moment to highlight that. Doesn't account for bias or bad surveys. What it does account for is natural variation. It doesn't account for you being a bad statistician. So let's take a look. Normally I'd issue this next problem as a challenge, but I'll do it with you. In 2005, the American Management Association did a little survey, 526 randomly selected US businesses. I'd probably circle 526 and write a little N by it because that is our sample size. One of the questions asked was whether the company had fired any employees, okay, for misuse of the internet while at work. Okay. Fired any employees. All right, good. Might underline the proportion of interest. What is this proportion? Proportion to have fired employees, blah, blah, blah. Gave a confidence interval of 229 to 292. Okay. So that sometimes we'd write that as 0.229, comma 0.292. So that is our confidence interval. Sometimes it's written as an interval, lower bound, comma, upper bound. Lower, comma, upper. Just as you'd write an interval in college algebra and calculus, right? Lower bound, comma, upper bound. The parentheses mean it's not technically included. Nobody's going to get that picky on you in stats. And if it's right on the boundary line, well, that gives you lots of room to talk. But so that sometimes confidence intervals written that way, but other times they'd be written as p hat plus or minus margin of error. How did I know this was a p hat? Because it's a yes or no thing. Did they fire him? Yes. No. They fired him or not. It's qualitative. Quality. What proportion answered yes? The proportion in the sample that answered yes, that's looking for p hat. So we have to say, what is p hat? Well, how do I find p hat? P hat is in the middle of the interval. Notice, if we add and subtract the same thing, our p hat is in the middle. Because we've added and subtracted the same value, the margin of error. So if we want to find p hat is the midpoint. P hat is 0.229 plus 0.292 divided by 2. Get your calculator. 229 plus 292 divided by 2. Oh, don't do that because my calculator knows order of operations. Divided by 2, 260.5. All right, so 0.2605. So that is our p hat. 26% of businesses said they'd fired an employee for misuse of the internet. And then we went up and down a little bit from that to say, okay, well, maybe this isn't true. What are we trying to find? We want to know p. P is the proportion of all US businesses. But p hat here is the proportion from our sample. Right, so we want to know what's the truth for all businesses of the United States. But we can't talk to all businesses in the United States. What's that called when you talk to everybody? It's a census, and it takes too long. It takes too long. We can't often do that. That's why we do confidence intervals, by the way, because we can't take a census every time. What's the margin of error for this interval? Well, we know the upper bound is, so we know like p hat plus your margin of error is 0.292. We know p hat. That's 0.2605 plus ME is 0.292. A little bit of arithmetic lets us find that the margin of error 292. 26.2605. Try again. 0.292 minus 0.2605 gives us 0.0315. About a 3% margin of error. So we're saying, here's the truth. Here's what we found from our sample, rather. If we go 3% up, 3% down, I think the truth is somewhere in here. How to figure out how far away to look? We'll talk more about that in a minute. What's wrong with being confident? Why don't we always use a 99% confidence level? And I implore you to look at this very informative Garfield graph. It's between negative 40 and positive 200. Okay, so the high temp is between negative 40 and positive 200. Great. Well, that's not helpful for me at all because that's like 80 plus or minus 120. So we think the high temperature is going to be in 80 degrees. But if we go 120 degrees up, 120 degrees down, pretty sure we're going to capture the truth. That's not useful. Why do I even watch the weather report? Why do I give a dang about the weather? Because I figure out how many coats I got to bring into work, right? If my if my interval is so wide that it doesn't help me make predictions, it has lost its value. Let's write something like that down. When an interval becomes so wide that it loses any predictive value, what good is it? Why have we done the work? Whenever interval becomes so wide that it loses any predictive value, why have we done the work? I tell you the weatherman tells you the high temperature is going to be between positive 200 and negative 40. You say, great. How does that help me figure out what clothes to put on in the morning? It doesn't. So we make predictions. We make confidence intervals. Why do we make confidence intervals? So we can do something with it. We do a confidence interval for the proportion of, you're working for a political candidate and you say, oh, crap, he's losing. Well, maybe targeted polling will help us say, oh, we work in this demographic, work on that demographic. Intervals help you make changes. They help you see if I've done something right. Do I need to change something? You make confidence intervals not just for funsies, to see where things are at. People make decisions based on these things. There's some reading here about 95% confidence that I'd like you to do. Go ahead and read this. Specifically interested in the what is correct. A 95% confidence interval means that, 95% of the time, when we calculate a confidence interval in this way, the true mean will be between the two values. 5% of the time it won't, but we don't know if we're right or wrong. You need to take a moment to read this. This idea of confidence interval is goofy, because 95% confidence interval doesn't mean there's a 95% chance that it's right. And that's weird. You listen to that and you said, well, that made sense. No. Go back and read. Go back and think about this. This is a sticky point. Sticky. Go back and figure it out. Read about the false interpretations. 95% confidence interval tells you how often does this method work. So how often does the method So summary of confidence interval, this is going to be an AP template that you just need to know. To interpret a confidence interval, we say we are C% confident that the interval from blank to blank captures the actual value of the population parameter in context. That just regurgitate. If we're interpreting a confidence interval, if we're interpreting a CI, we need to use this template. Might put it on a note card. We are C% confident the interval from this lower bound to this upper bound captures the thing. Remember, that's what these intervals are trying to do. We want intervals to capture the actual value, or contain, or includes. Convincing evidence, when we talk about significance tests, we'll talk about how intervals, if a parameter claimed is not in the interval, you have convincing evidence against a claim. Don't worry too much about that. That's a holdover from when Chapter 9 was included with this material. So down below, though, we'll read, researchers are interested in the effect of distractions on work efficiency. Okay, cool. 40 college students volunteered to be part of an experiment. Half are in a quiet room, half are in a loud room. Great. And then we made a 95% confidence interval for the difference between the mean completion times for the puzzle, music minus no music. So we're trying to estimate mu music minus mu no music. How long does it take to do the Sudoku puzzle? It's probably going to take longer, right? If you got music played in your ear. I don't know. And we found this interval was 5 to 11 minutes. So we would have made this interval by doing like X bar music minus X bar no music plus or minus some margin of error that we don't know about, right? So we're trying to estimate mu music minus mu no music. We're trying to estimate mu, but we can't know that true difference in means, unless we talk to everybody, sample everybody. Okay, so we didn't do that. So we have to do it this way, and we do it, and we get 5 to 11. So that's like, what is that? That's like 8 plus or minus 3. So the estimate's 8 plus or minus 3. Great. Can this be used to reject the null hypothesis of no difference? Reject a null hypothesis of no difference. So that would be a null hypothesis that mu1 minus mu2 equals 0. Is it plausible that the difference could be 0? Remember that word plausible. So 5 to 11, these are the plausible values. Is 0 in that? Because the interval doesn't contain 0, that's reason to suspect. I don't think that's right. 0 isn't a plausible value. It's not plausible that they could take on the average same amount of time because it's not in the range of plausible values. 0 isn't in there. 0 isn't plausible. 0 isn't captured. 0 isn't plausible. All right. So 0 isn't captured, 0 isn't plausible. So what do we have left to do? A little bit more on confidence intervals. We got to interpret these things. What do these things mean? What is a confidence level? All right. So humane society. I think we've seen some of this problem before. Humane society wanted to estimate with 95% confidence the proportion of households in the county that own at least one dog. And we got this. Okay. Take a moment, read this. Conditions for calculating a 95% confidence interval were checked and verified, and the resulting interval was 0.417 plus or minus 0.119. Okay. And we had a National Pet Products Association claimed that 39% was the value. Well, is 39% in that range of plausible values? Take this interval and do the adding and the subtracting. 0.417 plus 0.119, 0.536, okay. 0.536, and then the same deal, 0.417 minus 0.119, 0.298. All right, now the question becomes, is 39% in that interval? Does it give evidence that it is different? No, it doesn't. Since 0.39 is on that interval from 0.298 to 0.536. If you didn't take your college algebra, that means it is an interval of. We could also say is captured by the interval. It is a plausible value. All right, no, since 39 is on the interval, it's captured by the interval, it is a plausible value. Interpret the interval in context. Let's start all the way out here. We are 95% confident that the interval .298, 0.536 captures. What does it capture? The true proportion of households in the county that own at least one dog. Go back here. Proportion of all households in the county that own at least one dog. If you're not underlining, that's the parameter of interest here. If you're not underlining that, get in the habit of it. The proportion of all households that own at least one dog. Great. So we can interpret confidence intervals using that template. When you see something like this, template time. Cool. And you've got that template on the last page. Make sure you reference back to it. The other thing we might have to interpret is the confidence level. 95% of all samples of a given size from this population will result in an interval that captures the unknown parameter. This is another template that we need to know. AP is going to ask you to do these. And they've been getting more on the interpretation side. They've been less and less on the calculation, more and more on the interpretation. So this is another AP template that you need to know, that you need to memorize, that probably should end up on a Note card. In the long run, C% of all samples of the same size would yield an interval that captures the truth. How often does this method work? What's like the hit rate of the method? What's the success rate of the method? So we can think of this confidence level as the success rate of the method. And we need to remember that wider nets tend to be more successful. A couple thoughts. Confidence level, success rate of the method. 95% C% of this time, this method is going to capture the truth. 100 minus C% of the time, it's not. Do we know? No. When you're in class, I'll show you this applet. We will do this in class. Remind me to show you this in class. Cooler in person. And then the last thing I have, I believe, I got a few pages left. Ooh, I gotta quickly. I'm gonna take a quick pause. You take a pause too. I'll come back in a second. All right, had some Red Bull, ready to go. Go back and use that template from the previous page to interpret the 95% confidence level of that dog interval. Not the interval, but the level. Take a moment to do that. I'm going to pause. I'm just going to, when you come back, after you unpaused, you'll see the answer sitting right here. All right, 95% of samples this size, taken this way, will result in an interval that captures the true proportion of households with at least one dog. How often does the method work? Cool. True or false? If you increase the confidence level, the confidence interval is narrower. False. As the confidence level increases, your margin of error increases. As we become more confident, we make a wider interval. Down below, I'm going to bang through these pretty quick. This goes back to the interpretations of the confidence intervals, which you need to go back and read. If there's one thing you go read today, it's interpreting confidence intervals. What does the interval mean? What does it not mean? Does it mean that there's a 95% probability that the interval contains mu? No. There's either 100% or 0%. We just don't know yet. We can't know if the interval we make captures the truth because we haven't done census. There's a 95% chance that the interval contains X bar. No. There's a 100% chance because X bar is right in the middle of the interval. It's right there in the middle. It's got to be in there. C, this interval was constructed using a method that produces intervals that capture the true mean in 95% of all samples. That is absolutely true. That is an interpretation of your confidence level. 95% will contain an interval. I don't know that's just gibberish. And that last one is true and nuanced. The probability the interval captures mu is it either has it or it doesn't. Guys, think about this. There's a mean. It's sitting out there somewhere. What's the random thing that you do when you take the sample? Selecting the people. Once you've selected the people, your X bar is determined. That's not the random thing. Selecting the people is the random thing. Okay. So we have our interpretations of X bar. I'll skip that one for the sake of time. General formula for confidence intervals is going to be point estimate. Okay, and that's going to be like our p hat or our X bar, plus or minus our critical value, which is often going to be either a Z star or a T star, and the standard error. The standard error looks a lot like standard deviation. That's our estimate of standard deviation of sample statistic. That's going to be either SX over radical N or what's that? square root p hat 1 minus p hat over n. So we'll see you using those formulas again. Things you've seen before, things that shouldn't look too surprising. Don't worry about that right now. We're not actually going to use those formulas yet, and I'll present those formulas in a clearer way when we get to it. But this is where we're going. We're using our estimate that we would have thought about from the last unit. We would have used the distributions that those estimates are assumed to be under. And then we would talk about the spread of those distributions. And what do you think happens? As our confidence level goes up, we look more standard deviations away. Take a moment to read through the stuff I just rambled through. The standard deviation, we know about spread. Standard error of the mean, this is our estimate of sigma x bar. SE of x bar, that is our estimate, estimates sigma of x bar. So that's where we're going. One last thing for you. We talked about standard error. Don't worry about too much about these. Here we've got formulas going forward. These are the specific formulas we're going to be using going forward, and their formulas and their conditions. Now, there's a lot going on right here. This would make a great note card. But the one last thing I do want to show you. Two things. One's a theme that we've seen over and over. The larger sample size we use, the smaller the margin of error will be. Okay, larger sample size is obviously preferable, but sampling takes money. Once again, we're going to see that the margin of error inversely proportional to the square root of the sample size. This inverse square root relationship still exists, hasn't gone anywhere. Where does that come from? That comes from the fact that all those standard deviations have sigma n, excuse me, square root n, 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 square root n. N's are always in the denominator of a square root. We're always going to see that trend. So a couple questions for you. I'm gonna pause it and let you guys think about these ones. I'll come back. A couple quick ones you should have got by this point. If we want a larger margin of error, we need to be more confident, right? Wider net captures more fish. Wider interval captures more parameters. And the second one, if confidence level goes up, the confidence interval gets wider. Related ideas here. Last thing. Remember I told you those conditions that were on the middle of this board for chapter 7 weren't going away? Yeah, they're not. You need random sampling from a population of interest or random assignment. That's going to get no bias. So we always need that random condition. Sampling distribution is approximately normal. Two ways we can get that. If we're dealing with p hats, remember n p hat and n 1 minus p hat in this case will both need to be at least 10. Or in the x bar case, we need to have a sample of at least 30. Or population is normal. Or the box plot has no skew. Great. So we've seen those before. And the last one, subject or independent, we need their independent selection. And we need our sample size to be less than or equal to 10% of our population size. That's a lot in 8.1, and it's a lot of definitions, and it's a lot of words, and it's not a lot of math yet. And you probably wish we'd done some math, but we haven't. Sorry. You'll see that that is the end of 8.1. We've got some more here. I'm not going to do them because I feel like I've done enough. We can do them in class if you need more examples. Next time we'll talk about 8.2, estimating a population proportion, and 10.1, estimating a difference between proportions. And this, guys, that's polling. This is polling right here. This is how, you go back and you read the end of those 538 polls, and this is what they're doing. Something a little more complicated, but something like it. So that's it. 8.1 in the book. You got a homework assignment. We'll see you next time.